For fire pumps rated at 100 amps or more, the current National Electrical Code 2020 has specific requirements. A manually operated disconnect is required. It must be rated for 100% of the pump motor current. It must be located in a readily accessible location outside of the pump room. The conductors supplying the fire pump must be rated for 125% of the pump motor current. If the conductors are in a raceway, they must be protected from physical damage and moisture. Fire pumps must be connected to a power source that is separate from other loads in the facility. The power source must be capable of supplying the pump's full load current for a minimum of 1.5 hours in the event of a fire. Fire pumps may be connected to a non-metered power source to avoid interruptions in power during a fire. The most recent National Electrical Code 2020 requires a disconnect rated for 100% of the motor current. However, there is an exception that allows for a modified wiring scheme where the disconnect is omitted. To use this exception, the fire pump must be a dedicated pump, meaning it is only used for fire protection. The power supply must be direct from the transformer without any intermediate conductors. The transformer must be solely dedicated to supplying the fire pump. In this modified wiring scheme, a disconnect is not required before the pump control panel. However, this scheme must comply with all other applicable code requirements, such as the use of a dedicated power source and conductors rated for 125% of the pump motor current. Let's delve deeper into each of these requirements. Firstly, the disconnect switch. The requirement for a manually operated disconnect switch rated at 100% of the motor current is crucial for safety and maintenance. This disconnect allows for the fire pump to be isolated from the power supply during servicing or in emergency situations where the pump needs to be shut down manually. The readily accessible location outside of the pump room is equally important. This ensures that authorized personnel can quickly and easily access the disconnect switch without having to enter the pump room, which might be hazardous during a fire or other emergency. Secondly, concerning conductor sizing, the conductors supplying the fire pump must be rated for 125% of the pump motor current. This oversizing is necessary to account for the fact that fire pump motors can draw a significant amount of current, especially during startup. The 125% rating ensures that the conductors can handle the increased current without overheating, which could lead to insulation damage or even a fire. The requirement to protect the conductors from physical damage and moisture is also critical for ensuring the long-term reliability of the fire pump system. If the conductors are not properly protected, they could be damaged by impact, abrasion, or exposure to moisture, which could lead to shorts, ground faults, or other electrical problems. The use of appropriate raceways, such as conduit or cable trays, is essential for providing this protection. Thirdly, when it comes to the power source, the requirement that fire pumps must be connected to a power source that is separate from other loads in the facility is intended to ensure that the fire pump will continue to operate even if there is a power outage in other parts of the building. This separation can be achieved by connecting the fire pump to a dedicated transformer or by using a separate service entrance. The requirement that the power source must be capable of supplying the pump's full load current for a minimum of 1.5 hours in the event of a fire is based on the assumption that a fire could last for an extended period of time. The 1.5-hour runtime ensures that the fire pump will have enough power to operate continuously throughout the duration of the fire, providing adequate water pressure for firefighting efforts. Fourthly, the ability to connect fire pumps to a non-metered power source addresses the concern that metering could introduce a point of failure that could interrupt power to the fire pump during a fire. By allowing for non-metered connections, the code ensures that the fire pump will have an uninterrupted power supply when it is needed most. Now let's examine the modified wiring scheme that allows for the omission of the disconnect switch. Firstly, the fire pump must be a dedicated pump, used only for fire protection purposes. This requirement is intended to ensure that the fire pump is not used for any other purpose, such as supplying water for domestic use or irrigation. If the fire pump were to be used for other purposes, it could be subject to more frequent use, which could increase the risk of failure. Secondly, the power supply must be direct from the transformer without any intermediate conductors. This means that there must be no other loads connected to the transformer that supplies power to the fire pump. By eliminating intermediate conductors and other loads, the risk of a fault or overload affecting the fire pump's power supply is minimized. Thirdly, the transformer must be solely dedicated to supplying the fire pump. This ensures that the transformer is sized appropriately for the fire pump load and that it will not be overloaded by other loads in the facility. Even with this modified wiring scheme, all other applicable code requirements must still be met. This includes the use of a dedicated power source, conductors rated for 125% of the pump motor current, and protection of the conductors from physical damage and moisture. It is also important to note that the authority having jurisdiction may have additional requirements for fire pump installations. It is essential to consult with the local electrical inspector or fire marshal to ensure that the fire pump installation complies with all applicable codes and regulations. Let's elaborate further on the implications and technical aspects of each of these points. Disconnect switch alternatives are not allowed. The disconnect switch serves as a crucial safety mechanism. During maintenance, it allows personnel to de-energize the fire pump, preventing accidental starts and electrical hazards. In emergency situations, it enables manual shutdown of the pump if automated systems fail or if the pump itself malfunctions. This is particularly important in scenarios where the pump might be exacerbating a fire or causing other damage. The requirement that the disconnect be readily accessible outside the pump room is a deliberate safety measure. Fire pump rooms can become hazardous environments during a fire, with potential risks including smoke, heat, and flooding. Placing the disconnect outside ensures that firefighters or maintenance personnel can quickly and safely de-energize the pump without having to enter a potentially dangerous area. Regarding conductor sizing, the 125% rating is not arbitrary. Fire pump motors, especially during startup, can draw significantly higher current than their rated full load amperage. This inrush current can last for several seconds, and if the conductors are not adequately sized, it can lead to overheating, voltage drop, and premature insulation failure. The 125% rating provides a safety margin to accommodate this inrush current and ensure reliable operation of the fire pump. Furthermore, the type of conductor used is also critical. Conductors must be rated for the appropriate temperature and environmental conditions. For example, conductors installed in high-temperature environments or exposed to moisture must have specific insulation ratings to prevent degradation and failure. Appropriate raceways, such as rigid metal conduit, intermediate metal conduit, or electrical metallic tubing, provide physical protection for the conductors against impact, abrasion, and other forms of damage. These raceways also help to contain any potential arc faults or short circuits, preventing them from spreading and causing further damage. In areas subject to moisture or corrosive substances, non-metallic raceways or special coatings may be required to prevent corrosion. The separation of the fire pump power source from other loads is a fundamental principle of fire pump system design. This separation ensures that the fire pump will continue to operate even if there is a power failure in other parts of the building. There are several ways to achieve this separation. One method is to connect the fire pump to a dedicated transformer that serves no other loads. Another method is to use a separate service entrance for the fire pump with its own main disconnect and overcurrent protection. In some cases, a combination of these methods may be used. The 1.5-hour runtime requirement for the power source is based on historical data and fire protection engineering principles. Fires can burn for extended periods, and the fire pump must be able to operate continuously throughout the duration of the fire to provide adequate water pressure for firefighting efforts. The 1.5-hour runtime is considered a minimum, and in some cases, a longer runtime may be required, depending on the specific hazards and risks associated with the building or facility. Power sources can include on-site generators, which are used as backup to the utility grid. These generators must be sized to provide the full load current of the fire pump, as well as any other essential loads that need to be powered during a power outage. The generators must also have sufficient fuel capacity to operate for the required 1.5-hour runtime. The option to connect fire pumps to a non-metered power source recognizes the critical nature of fire pump operation. Metering devices can introduce potential points of failure that could interrupt power to the fire pump during a fire. By allowing for non-metered connections, the code ensures that the fire pump will have an uninterrupted power supply when it is needed most. However, even with a non-metered connection, there must still be provisions for monitoring the power consumption of the fire pump. This can be achieved through other means, such as installing a current transformer on the fire pump feeder or using a power monitoring relay. When considering the modified wiring scheme, it's important to understand the rationale behind each requirement. The requirement that the fire pump be dedicated to fire protection ensures that it will not be subjected to frequent use or other demands that could increase the risk of failure. By limiting the pump's use to fire protection purposes only, its reliability is enhanced. The direct connection from the transformer without intermediate conductors minimizes the potential for faults or overloads to affect the fire pump's power supply. Intermediate conductors can introduce additional points of failure such as splices, terminations, and connections. By eliminating these intermediate conductors, the risk of a power interruption is reduced. Similarly, the requirement that the transformer be solely dedicated to supplying the fire pump ensures that the transformer is sized appropriately for the fire pump load and that it will not be overloaded by other loads in the facility. Overloading a transformer can lead to overheating, voltage drop, and premature failure. When implementing the modified wiring scheme, it is crucial to ensure that all other applicable code requirements are still met. This includes conductor sizing, overcurrent protection, grounding, and bonding. It is also important to coordinate with the local electrical inspector or fire marshal to ensure that the installation complies with all applicable codes and regulations. The authority having jurisdiction plays a critical role in ensuring the safety and reliability of fire pump installations. They may have additional requirements beyond those specified in the National Electrical Code based on local conditions and specific hazards. It is essential to consult with the authority having jurisdiction early in the design process to ensure that the fire pump installation meets all applicable requirements. For example, local codes may require additional testing or commissioning procedures for fire pump systems. They may also have specific requirements for the location and accessibility of fire pump equipment. In some cases, they may require the use of specific types of equipment or materials. This discussion highlights the importance of understanding the National Electrical Code requirements for wiring fire pumps. By following these requirements, electrical professionals can ensure that fire pump systems are installed safely and reliably, providing essential protection for buildings and their occupants. The information presented here is intended for educational purposes only and should not be considered a substitute for professional engineering advice. Always consult with a qualified electrical engineer or fire protection engineer before designing or installing a fire pump system. Remember to consult the latest edition of the National Electrical Code and any applicable local codes or regulations to ensure compliance. Regular maintenance and testing of fire pump systems are also essential for ensuring their continued reliability. This includes periodic inspections of the pump, motor, controller, and associated wiring and equipment. Any deficiencies or problems should be addressed promptly to prevent potential failures. Fire pump systems are a critical component of building fire protection systems, and their proper installation and maintenance are essential for ensuring the safety of life and property. It is important to take these requirements seriously and to follow all applicable codes and regulations. Furthermore, keep in mind that fire pump installations are not a one-size-fits-all solution. The specific requirements for a given installation will depend on a variety of factors, including the size and type of building, the occupancy classification, the available water supply, and the local codes and regulations. It is important to carefully evaluate all of these factors before designing a fire pump system. The design of a fire pump system should be entrusted to qualified professionals who have the knowledge and experience necessary to ensure that the system meets all applicable requirements and will perform reliably when needed. Electrical contractors who install fire pump systems should also be properly trained and qualified to perform their work. They should be familiar with the National Electrical Code requirements for fire pump installations and should have the necessary tools and equipment to perform the work safely and correctly. In addition to the electrical requirements, there are also mechanical requirements for fire pump systems. These requirements relate to the pump itself, the piping, the valves, and other mechanical components. The mechanical requirements are typically covered in other codes and standards, such as the National Fire Protection Association 20 standard for the installation of stationary fire pumps for fire protection. It is important to coordinate the electrical and mechanical aspects of a fire pump installation to ensure that the system functions properly as a whole. For example, the electrical controller must be properly integrated with the pump and motor to ensure that the pump starts and stops reliably and that it operates at the correct speed and pressure. The piping must be sized appropriately to deliver the required flow of water to the fire protection system. The valves must be properly selected and installed to control the flow of water and to prevent backflow. The fire pump room must be properly ventilated to prevent overheating of the pump and motor. The fire pump room must also be protected from flooding and other hazards. In conclusion, fire pump systems are complex and critical components of building fire protection systems. Their proper installation and maintenance require a thorough understanding of the National Electrical Code, other applicable codes and standards, and the specific requirements of the installation. By following these requirements and working with qualified professionals, you can help to ensure that fire pump systems will perform reliably when needed, providing essential protection for buildings and their occupants. Also, consider that the technology surrounding fire pumps and their control systems is constantly evolving. Staying informed about the latest advancements can lead to improved system performance, reliability, and efficiency. For instance, modern fire pump controllers may incorporate features such as remote monitoring, diagnostic capabilities, and advanced motor protection. These features can help to identify potential problems early on and prevent costly downtime. Similarly, advancements in pump technology have led to the development of more efficient and reliable pumps that require less maintenance. By keeping up with these advancements, you can ensure that your fire pump system is operating at its best. In addition to the technical aspects of fire pump systems, it is also important to consider the human element. Proper training for building personnel and fire department personnel is essential for ensuring that they know how to operate and maintain the fire pump system correctly. Training should cover topics such as the location of the fire pump room, the operation of the controller, the procedures for starting and stopping the pump, and the troubleshooting of common problems. Regular fire drills should also be conducted to familiarize building occupants with the fire protection system and to ensure that they know what to do in the event of a fire. By addressing both the technical and human aspects of fire pump systems, you can create a comprehensive fire protection strategy that will help to protect lives and property. This is essential for electrical contractors, engineers, and building managers.